I think we are live right now. Yes. So welcome again. And maybe we can start with smoke or, I'm sorry. I am hearing myself right now. Okay. Maybe we can start with smoke now. I will share my screen to look at the smoke. Yes. So can you see my screen right now? Okay. As you can see, CMOC is a scalable, interactive model of an off-world community. The abbreviation of it is CMOC. And in here, there is an explanation about the what's going on in the website and the other kind of informations in the starting point. When we click on the proceed part, it asks us from signing in or up, but it's possible to create scenarios without creating any kind of application, not application. Yes, count. Thank you. We can sign in as a guest, or we can create an account and proceed in that way. So for now, I am signing as a guest and starting to create some configurations. So in that main menu, we can create new configurations, or we can load our simulation data, and they are kindly as some sort of feedbacks also. So for the new configuration, when we click on that button, we reach a list of variables on the website. So there is a lot of alternatives to create these scenarios. So there is, in the website, there is already settled scenarios, which are one human and reddish, four humans and garden, and SAM, one human and garden. And also we can create custom scenarios also. So for example, I'm just clicking four humans and garden scenario. So as you can see, there's an information in here when we click on that eye. And there is a lot of explanations actually in the website about these variables. And for the location, we have only Mars option. And we can change our mission duration. We can change crew quarters according to these numbers. But for the project, we will changing them as what we need from our scenario, because we will change the scenarios, and also we will look at the data, outcome data, in order to compare what's needed and what's done. So for the inhabitants, I think we can just go maximum in 10 people, and also we can look at what's going on inside this the configuration from the information part of the website. So, for example, food supply, they created some sort of table, and in order to create some sort of correlation between inhabitants and the duration, they created a table here for the needed required food kilogram numbers. And for the life support, it is, if you can remember from the yesterday, the environmental control and life support system, they are explaining in a brief way about this issue in here also. And for the greenhouse, actually, it's very interesting because we can add different kind of plant species in here. And in our project, we will use these greenhouse also. Maybe in our scenarios, we will not put any greenhouse, or we will use these greenhouses as we need it in our according to our scenarios. Then you can reach the power generation and power storage part in the end of this list. So I will just, if you can remember, I just changed the inhabitants. So the scenario is changed as a custom. I will change it again for humans and garden scenario. And when we click on the launch simulation, it started to analyze these inputs in the Mars conditions. And as you can see, my mouse is just turning blue and it came. Yes, it came. And in here, while we are looking these outcomes, you can see that there is an option that we can add another panels and we can change or remove these panels. For example, when we want to add panel, we can select our topic in here. For example, habitat view. When we click on them, another kind of panel is just coming here, and we can add or remove how we want. So, for example, that, or I'm just adding randomly right now. I think storage level is here, so maybe inhabitant status also in here, maybe that. So we can add what we want in here also. CMOC is produced a view for the habitat in here as a default way. So we will change it according to our Rhino file, and we will look at what's going on in there also. So I will yes, no. And as you can see here, it's going day by day right now, but it's already simulated all of the data, so we can just click on that and go forward or backwards in order to understand what's going on in this period, for example, or at the end of the our mission. And in there, we can see all of the information about this scenario. And if you want to download this data, we can just click on that and download simulation data in JSON file format. And I could kindly ask that, could you just look at what's going on in your computers about the website? What is the differences or the other kind of differentiations, what's going on in the simulation? Because it's important that in order to understand this, what the scenario, it's important to look at the information given to us. If it is okay for you, maybe you can look at in 15 minutes. Then if you have any kind of questions about this issue, we can look at them together. So maybe I can give you 15 minutes to analyze the data or the website. Is it okay for you?
Yes.
Okay,
Yes.
okay,
Yeah, I was looking at it. It's similar, like there are no changes. So Yeah, okay. We'll just go through like each of the options and see the different
Okay.
panels. Okay.
We will be here. We will answer your questions while you are looking at that. But it's important that you also look at and to understand the situation that here. So
All right.
I'm stopping my shares, and then we will wait for your questions.
Okay.
I have a question. Do I need to do anything to make the consumption low or the production high and stuff, or I just don't do anything and just watch it?
Yeah, I couldn't understand the question actually. When you decide the configuration, after that you just watch the actually outcomes. Then in the project we will change these issues and create our volumes according to these changes.
Oh, okay.
By the way, you can adjust the slider at the bottom of your screen so that it speeds up. You don't need to watch the whole process. You can just slide this to the rightmost and see the end results. But if you have asked if there is any way to reduce the consumption and increase the productivity after the simulation, it's not possible because when a mission is set for Mars, it is the variables are already determined, and there's nothing you can do after the mission starts. That's the logic. But we will handle the data processing part to have some strategies for these maximum values, the consumption and production.
Okay, I understand. Thanks.
You're welcome.
Yeah, I had a small question. So I was looking at the atmospheric monitors, and like around 340 hours, like around that mark, the CO2 status becomes maximum. It goes very close to 1%, and then it drops. So I was looking at the monitor, nothing else changes, only the CO2 kind of peaks up around this time and then drops. I was wondering why this happens. Then the rest of the time it's still low. So only at 340, I think, right? It reaches the highest. I was wondering why this might be happening.
Do you have a greenhouse in your simulation layout, or just the people?
It was both human plus garden.
Okay. So the thing between plants and people is that they somehow balances the other productions and consumptions, because as you know, plants consume carbon dioxide while humans producing it. That's why it peaks up at some time, but during daytime the plants are able to consume carbon dioxide and produce oxygen, but during the nighttime it's inevitably taking the carbon dioxide production up to a certain level.
Okay, and I think it might also have something to do with the growth of the plants, probably. Like when it slowly grows and it's able to consume the carbon dioxide better. Okay, all right, thank you.
You're welcome.
And in addition to that, I think you are looking the panel that's called, I'm not sure, but can you share your screen so we can understand each other in a very clear way? Okay. While you are sharing, I could try to understand the situation also. For example, in here, I will change my shape. Oh no. Okay. You are talking about this part, right? That part. Okay, I understand. Actually, what Odan just said is right, and also there's an huge differences between them. So it became in peak and low at these periods. I'm not sure if I could explain myself clearly, but.
Yes, and I got it.
Okay.
Yeah, muted. Sorry.
So if you want, you can stop your sharing. Up to you.
By the way, have you get a chance to try different scenarios? Because we will be needing for the seeing our strategies clearly. If you change your settings before starting the simulation, try to observe the differences between your scenarios so that we can select the data to start designing a habitat on Mars. We will share the Python code for that analysis, and you will also get a chance to observe your data differences in terms of an architectural data, like how my layout changes the need of a space in terms of habitation or greenhouse. You will see in meter cubes in the code, so that you will more or less understand and try a layout or find a layout that fits your architectural needs.
Well, I hope it's okay for you to examine the website. So maybe we can proceed to our other lecture that we started yesterday.
Oh, I have another question. My stimulation stopped. Is it because of the network condition, or it just stopped?
Yeah, sometimes it cannot proceed all of the data. If you can share your screen, maybe we can look at that.
Okay.
Most probably the duration. If the duration is too high, the simulation is having a hard time processing all the data. Maybe you can reduce the duration time.
There's something wrong with sharing the screen. It told me to reopen it. I think maybe that's the problem. Let's continue. I think, yes.
Okay, the participant number and also the duration is affecting that issue. And if you can reduce them, it will be better for the process. So is there any questions about this issue? If it is not?
No. All good. Yeah.
Okay, then floor is yours, Ozan Hocam.
Thank you. Yep. So we were left at the Python part. I will only make a brief introduction about what Python is and how it works, what makes it so popular. I will just briefly mention them, and we will see a working code that takes the data from the simulation and calculates the architectural space needs in a Martian habitation. Firstly, let's go a bit further about Python. So the Python is a very popular language, and it is a high-level language. I have, if you remember, I have mentioned what a high level and low level means yesterday. When you are closer to the main memory, the language becomes a high level language. And if you move towards the CPU or the computing unit, it becomes low level. And the difference, the main difference between the low level and high level language is low level languages like assembly are hard to write, hard to read, hard to understand, and hard to learn, but they're faster. And if the language is a high level language, it becomes slower, but it becomes very easy to write and read and learn. So Python is a very user-friendly language where you can instantly understand what a code does if you know the basics or fundamentals, because it's like the English. It's really basic. And it began late in '89 as a hobby project. It's interesting. It's not a scientific project or anything. It was just a person's hobby at the start, but it became a popular language till now. And the Python mostly regarded as a snake, Python, but it's actually taking its name from Monty Python, which is a comic troupe from England. If you haven't watched Monty Python, I strongly recommend. Their sketches are really fun. And Monty Python actually added interesting things into the world of programming. The word spam, when you get the spam emails, word spam is also coined by Monty Python. So it's another interesting fun fact. So what are the advantages of Python is numerous. And firstly, Python has dynamic types. So what it means is, it's really interesting. Your code is not static anymore, it's dynamic, because your code functionality can change during runtime. So if you, for example, write a function to calculate anything, you can modify your functions with the Python code itself. So it's really adaptive. It's a really adaptive language. And the other thing is, Python is not a compiled language. It's an interpreted language. What it means is, compiled languages needs another process to be packed. And when you double click, for example, the exe files in Windows, they're compiled languages actually. They're compiled programs. But compiled languages are a bit old school, because if your program has a bug or has a flaw that you need to rewrite, you need to compile your program, test it, and see the result and try to figure out where the problem is. But the Python is interpreted language, and it is executed line by line. So when your program has a bug or a problem, you will instantly see your program stops at that line, and you can understand the problem is related to that line. So it's a really good advantage. So that's the difference between the compiler and the interpreter. So the Python reads the source code and generates the output directly with the interpreter, but compiled languages like Java or C family, C languages, need to be compiled and translated to a machine code, and then you get the output. So if your program has a bug inside your line, you need to figure out you need to check the output and figure out where the mistake could be. But if your program is written in Python, you will see that your output will be stopped at here, for example, and you will instantly understand that my mistake is somewhere here. But it's really easy to understand and debug Python code. And other advantages, it's really easy to use. They call it programming at the speed of code. When you think of a solution, and if you're using Python, writing the code of that solution usually takes 10-15 minutes. But if you're, for example, using C or C# or C++ or Java, you need to think 5 times more in order to write the code of that solution, and you need probably 20 to 30 minutes. Obviously, it's about how your solution works, or how is it easy or hard. But mostly Python syntax is really simple, and you can program at the speed of thought. And it's really powerful because it's object-oriented. What it means is everything Python uses and produces is an object. So, for example, if you're whether if you're using oxygen levels in the Mars level on the Mars habitat or plant size, it's all objects, so you can manipulate and calculate all of them together. It's really easy. The other languages have some strict types like integers or floats, and you need to declare them not as objects but as the types that it belongs to. And it's a glue language which can be integrated with other languages. It's really easy to use in combination with JavaScript or in combination with C#. You can always use Python at an intermediate level, in which we will also do it in a way. We will take the simulation data from CMOC, we will process it and analyze it with Python, and then we will take the data from Python and proceed to the Grasshopper, which is a visual programming language, runs in a different world like Rhino. And it's a bit outdated. It says that it runs everywhere, Windows, Linux, Mac, Linux, Mac, but it's a bit outdated because nowadays every language runs everywhere. It's not a thing anymore. It was a bit a problem back in the old days, but it's not a problem anymore for any language. The other powerful thing that is Python is an open source language, and it has a strong community. When you, for example, encounter a problem in Python, when you Google it, you will see that hundreds and thousands of people having same problem and hundreds and thousands of people having solution for your problem. So it's a great thing to Google your problem and get your solution in minutes. So it's not that easy in other languages. For example, if you are using Visual Basic inside Grasshopper, and when you Google your problem, it's not that easy. It's a bit time consuming. You will seek for the forums to see if anyone has an idea about their problem. But if you're using Python, it's really easy to find a solution for your problem. And it's dynamically typed. It is like what it means is if you're using any other language like C, for example, you need to declare that. By the way, it's horrible to write with the pen. I have the text. Okay, if you're using, for example, C family language, you need to declare that A is a variable and it's an integer and its value is 8. But if you're using Python, what you need to write is A is equal to 8. And Python automatically understands that it's an integer and it's a mathematical value. But for example, if you want to declare a string, which is the text-based data, we need to use it in C, like var string B is hello. But what you need to do in Python is tell that B is equal to hello world. And that's it. Python automatically understands the type. So what to be done to be feel comfortable in Python is it all starts with computational thinking, whether if you're using Grasshopper or any other language, the fundamental thing to understand is the computational thinking. That's why I suggested the Blockly first before proceeding and diving into Python resources. It is really crucial to learn how to think like a computer, because computers have different natures than us. And sometimes it's really easy to think a solution as a human being, but it's not that easy to write a program for computers so that computers can also read the set of instructions that you have given and provide you a solution. So it's really important. And then you can dive into basic programming terminology and concepts. Like they're all language independent, whether you are using a high level language or low level language. A for loop is a for loop. And the difference between the languages is just the syntax. It's just about how you write it, like the integer and string example that I have given with C and Python a minute before. When you get how you can solve the problem without writing the actual code itself, is called pseudocode. And people always write pseudocode so that people know Python also understands it, and people who know C also understand the solution and implement it. So you need to learn the basic programming terminology and concepts. For example, what are the data types? Integers, strings, floats, dictionaries, lists, arrays, like that. And the concepts, obviously. What is a loop? What is an iteration? What is a recursion? What is a for loop? What is for each loop? What is a while loop? And the list goes on. What is a function? What is a class? And the basics of data types and structures. Of course, it's really important, because if you don't know what kind of data you want to handle, mostly you will have hard time programming it, because you need to control each and everything in your program. And the programming literacy and making use of it, it's really important. Sometimes you don't need to actually write the code to its every bit. Sometimes you find solutions from other people, and sometimes you use it. But if you have programming literacy, you will it will be very easy for you to understand how the other people's solutions work. And when you understand it, you're really free to use it. You can modify it to your own needs. You can integrate some intermediary programs and add or build something on top of other people's solutions. And it's really the merit of programming. Programmers or developers mostly does not reinvent the wheel. They use the ready-made solutions, but since they have literacy, programming literacy, they understand how the solution works, and they're free to use and modify it. And of course, using programming to analyze data, which we will be doing today, and developing programs for problem solving, which is the most it's like more advanced than understanding the code, but it's building it. It's building the program itself for problem solving. So these were the resources that I have mentioned yesterday. You can always go and check them. But of course, don't miss out the computational thinking or algorithmic thinking resources before diving into Python. And it's the flowchart of the program that we have developed for this workshop. It basically takes the CMOC data and process it and gives you the data that you will be needing to design or control your habitat on Mars. But before proceeding to the flowchart, because it will take a bit time, I will focus each and every detail on that, because we want you to understand the logic of the code clearly so that you can use it, and for the future you can develop your own programs. We think that it's really important. If you want, before proceeding to the detailed description of the flowchart, we can give a break and then continue with the logic of how our code works.
Okay, all right.
Okay, great. Welcome back. Are you ready to dive into the code flowchart?
Yeah, I think so.
Hi. Okay then. There's the screen back again. So let me first show you how the code is like. It's a Jupyter notebook. So when you see a black box, it means that it's the code executed by Python. But inside the code, within the code, you will see also some descriptions. And if you see small boxes, small black boxes inside the descriptions. By the way, it could not be a black box or white box if you're using a light theme. It will mean that it refers to something inside the code. So it's, for example, storage capacities. And you can see that storage capacities is here inside the code. And it's the for loop and for is here. And print function is here. Oh, let's clear the drawing. So it's not really easy to understand the code itself by just looking at the syntax. So these are some basic things, but when you go and dive into the code, it becomes a bit complicated. Like, for example, it's not easy to understand what it does just by looking the code itself. If you don't know Python syntax, and if you don't feel comfortable in writing Python syntax, but it's a really basic code. And instead, I will show you the flowchart. So the flowchart is made on a tool called Whimsical. It's like Miroboard, but it's more suitable for programming. If you have heard or used the Miroboard, it's really just like that, the Whimsical, but it's kind of more structured and more strict, let me say, to fit the needs of a programmer. So I'm using the Whimsical mostly to visualize the flowchart of my code. And everything starts from here. So it's the data file, and there are some notations used in programming, like this cylinder. Mostly in programming, the cylinder indicates the database. Actually, we don't use the database in this example, but I've just indicated this as a database because it reads the whole raw data that you downloaded from CMOC. And I'm using those other things. This is the diamond is for the decision point, and the rectangles are for the data, either input or output, or an intermediary thing. And in most of the case, rounded circles or rounded rectangles are for the functions or the mathematical operation. So the legend is something like that. And what the code does is really simple. Believe me, it's not it's not maybe look easy when you have first sight, but when you go step by step, you will understand each of the process. And when you have some question or when you want to discuss something to a bit more detail, you can always interrupt me so that I can explain that part. Okay, let's start. So it all starts with the data itself. Let me also group it. Yeah. So this is the JSON file that you have downloaded from the CMOC simulation software. And it is called JSON format. JSON is JavaScript object notation. It is a common data file used in web applications. When you, for example, handle something within the websites, you will most probably see the JSON format. And Python has a module or a method that handles the reading JSON files. So what you need to do is call the module, which is called JSON in Python. And you call the load method, which loads the file into Python. And what you need to pass is the key or the label of the data that you want to retrieve. So in this JSON file, you can always use JSON visualizers. And if you Google JSON viewer, you will see that there are lots of online viewers. And oh, sorry, I need to copy and paste. Yeah, this is the data file that you are downloading. It's not that readable, but if you open it with a text editor which capable of formatting, you can format your selection. I'm using Visual Code for that. And it makes your data more visible automatically. It structures your data. And you can see that there is a object called caret, and there's a description, there's the unit, there's the nutrition values inside the caret and the label. And when you scroll a bit further, you have, for example, the value that indicates the day. Remember the slider at the bottom of the CMOC is the 193 among all of the duration. And inside of that data, there are carbon dioxide, oxygen, potable, and kilowatt hour value. And inside all of them, that there has value and unit. For example, carbon dioxide at that day is that much within a unit of 1 kilogram. So in order to see it more clearly, you can use those JSON viewers. Just copy and paste your text data to a visualizer, and you can go to viewer. Yeah, you can open up your data like that, so it's more readable, right? For example, there's parameters objects inside of it, the game ID, the unique ID, and the website gives to you. Number of steps is the duration of your mission. And there are total production values. Each of them indicates a day, and in each day you have those values. And the code that we have written for this project handles all the data processing issues and will give you the data that you need to build a habitation on Mars, the volume value. So going back to the whimsical. So there are two main things that we have calculated. The first thing is to calculate the storage capacities, and inside the storage capacities, if you examine it in JSON viewer, you will see that inside the storage capacities, there's the crew habitat, greenhouse, water storage, nutrient storage, ration storage, power storage, carbon dioxide storage, and these should be separate. Wheat, cabbage, strawberry, if you have them, obviously. If you don't have it in your simulation, when you start, it will not be appearing here. But if you select a scenario that contains those values, you will see that storage capacities will contain those values. But we will not be using all of them. We will just take what we need from this data and process it. And from storage capacities, what we have taken as the first step is the crew habitat. So inside the crew habitat, you will see 4 values. One of them is nitrogen, one of them is oxygen, one of them is carbon dioxide and hydrogen. So we take the crew habitat data, and inside the loop, this is a bit, this is the trickiest part of the code, actually. What it does is, it first takes maximum level for nitrogen inside the habitat, which we call maximum habitat nitrogen. We start with 0 because the code itself cannot know what the value is at the start. So we give 0 as the starting point. So our code will know nothing at the start, but it will know that we should be using this variable, and we will be calculating this value. And initially it starts from 0. And what it does is, these are collection of values, and there are some nitrogen values for day 0 or day 1. There's no thing called day 0, but programmers like to count from 0. So day 1, nitrogen level is something like 5.2, let's say. And then on the second day, it goes up to 6.7, and then it reduces to day 3. It reduces to 3.1, and then goes up to 8.4, and so on. So what the code does is, it takes the value for each day, and while while our code looking to the value inside each day, there is an if condition. And what it does is it checks the nitrogen value, check if this value is greater than the value that we have assigned initially. And if it is the case, it updates the value. So it deletes the 0, makes it 5.2. And then it proceeds and goes for all days. And what it does is, if it is greater than 5.2, the previous one, it updates the value, it deletes the 5.2, makes it 6.7, and then it proceeds to 3.1, checks if this is greater than this. No, then it proceeds and continues so that it finds the maximum value during our whole Mars mission. So why do we need that? We need the maximum value of each gas value, because we will be needing to understand what are the extreme conditions that we will face on this Mars mission, so that we can build a habitat which is big enough to withstand the maximum value. So for example, if all of those values goes up to 100 or something, we will convert them into meter cube, because they are all in kilograms. We will convert them into meter cubes so that we can understand that, okay, we need total of 800 meter cubes to contain those values in the Mars. Okay. Great. So this portion calculates the maximum values encountered in that mission for nitrogen, oxygen, carbon dioxide, and hydrogen separately. It does all those steps, checking if it exceeds the current maximum. If it is the case, updating the maximum value. If it's not the case, passing that day and continue to that day. And this thing continues as the same structure for the greenhouse. So the difference between this and this is only one calculates the value for the habitat, one calculates the value for greenhouse. As you can see, it visually is the same process for the greenhouse. And for the water storage, only difference is the values calculated. One is for the potable water that you can drink. One is for the treated, which means that the water was not originally drinkable, but you treat them well so that people can drink it safely. And one is the urine, which is not drinkable, obviously. And the process is very same, and we calculate the maximum for each of them. Nutrient storage is the same, but food storage is a bit different, because inside the data structure, we can observe that in each day we have fertilizer, biomass, and waste separately. But for the food storage, we need to calculate the total, because you may have carrot, you may have, I don't know, potato, you may have cabbage, and so on. You may have different types of food and different amounts of food depending on your scenario. These are static values, but these can be dynamic. These can change according to your scenario. Obviously, this values can also change if you whether if you have greenhouse or not. But what it changes is not the number of data that you have, but whether you have it or not. So you either you have biomass or not when you select the scenario. But for the food storage, it's a different thing. And what we need to do in here is taking the items inside the food storage with the items method of Python. And for the items, we just like the initial values set as 0 in the previous part, we actually made a similar approach here, like setting the food total to 0 initially for each day. And in each day, what we do is, for example, let's say that we have cabbage for 3, I don't know, carrot as 1.2. And that's for the first day. And we have another day which has the different amount, like carrot 2.4, cabbage 9.1. So what it does is, remember we were looking for each day and just looking at the numerical value. If that is greater than the current total, we were updating the value that we have. But since the thing is different here, we calculate the food total by adding those values for each item inside each day and calculating as 4.2. This portion handles that. So we get the items, we take the items value, and we add them up, which is indicated by plus equals in Python, and we add them up to food total. So it's now 4.2. Everything clear up to now?
I have a little question.
Yep.
Is this I see this food storage items is in the round circle and all those waste biomass, this is in the rectangular circle. Rectangular. I mean, is there any difference between between those circles?
Yeah, great question. Mostly the rectangular ones are used to indicate data, either if it's input or output. So it's like calculated value of food total 4.2, like that. And circular ones are for the mathematical operations. So since this portion is not the data itself, but the method that we use to calculate the 4.2 by adding those up, that's why they're the circular. This is also the case for items, because this is not the data itself, but this is the method that takes the items inside each day, cabbage and carrot.
Okay. Oh, I see.
Okay, that's the difference. So in this case, that's the rectangular here, because they were the values itself. But in here, we have more values inside that object. So we need to get those items and add them up.
So the food total below is data itself.
Yeah, food total is the data itself. And the food total is the value, total value, calculated for each day. For example, it is 4.2 for day 1. And here is day 2. And food total is 11.5, which is the total of cabbage and carrot. And there is another data called maximum food total, and it calculates the maximum value of total food during the whole mission. So if 4.2 is, 11.5 is greater than 4.2, the maximum food total will be 11.5. But of course, the process continues. There is day 3, there is day 4, and whenever this if condition finds that, oh, this is, I made a mistake. This should be, no, I didn't. Sorry for that. Whenever it finds that food total of that day is greater than the maximum food which is encountered till that day, it updates the maximum food total value, which is indicated by that arrow. So if the day 3 is, for example, maximum or total of 20 or something, it will update the 11.5 value and it will write 20 instead of that. But food total changes every day because it's the total of each day separately. So that was a bit trickier than the other data that we have processed, but it's not that hard. It requires a step further since it contains multiple items. So you can observe that. Sorry. You can observe that the same logic which is used here is same with here. What we needed to do is just to take, let's use another color, just to take 2 more steps before proceeding to that. Okay. And the rest is a bit easier because we, for now, till now, we have calculated all the maximum values for habitat, greenhouse, water storage, and nutrient and food. And we use a simple conversion table which converts each of the element or each of the item from kilogram to meter cube. And these values are static, so it's just a simple multiplication. So if you, for example, have 1 kilogram of nitrogen you will multiply with this value. And it is equal to this amount of meter cube of nitrogen. It's that simple. We just multiply the value that we have found in kilogram with that value to convert it into meter cube. Because we will be using meter cube to adjust our structures or habitat units with meter cube. As architects and designers, we don't use kilograms to calculate our volume needs. We use meter cube. So these values are static, in which you can find it via a simple internet search. So we just multiply all the kilogram values to convert them into meter cube. And we store them in different variables, just appended by meter cube at the end of each variable. And what we do is summing all them up. Maybe I should add a sum function here. So we sum all the values, or we have all the gases calculated in meter cube, and if we add them up, we have a total meter cube, which we need to sustain life on Mars in storage habitat. So we calculate storage habitat value by adding those up. We calculated the storage greenhouse meter cube by adding all the items that greenhouse contains. And we calculated the ECLSS storage that we need by adding those water meter cube value. Okay, everything good? And we have a small portion, which is a bit more trickier, but you will understand those easily because it's not that different than the other part of the code. So since we have taken storage capacities to calculate all those values, this time we are taking total consumption values to calculate how many photovoltaic panels that we will be needing in the Mars habitat. So we get the total consumption data and we use items method again to retrieve the items inside the total consumption object. And what we do is let me write the text here. So what we do is we open up a value, which is our count, and set it to 0 initially. And we also set total energy consumption and set it to 0 initially again. Oh, I cannot move it. Horrible. Okay, no problem. So when we get the items, we also have the data inside for each day. And this time, it is not on a daily basis, but it's on an hourly basis. So we we have the data inside each hour actually. And what we do is in each step, we increment our count by 1 because it means that we have passed an hour and our count should be 1 instead of 0 because one hour have passed in our code. So we take the hour count and increment for each day. So in each hour. So when hours are passing, our code is doing that. So one hour passed, it adds 1 to the value of 1, and yes, 2, and continues. It makes it 3, it makes it 4, and so on, until the mission finishes. And what we do here is adding the getting the total energy consumption value from the total consumption items, and we add the value of that energy consumption at that hour to the total energy consumption. Let's say that it consumed 7 kilowatt hours, so it adds 7 to it for day 1, hour 1, and another hour passes. Let's say that for day 2, hour 2, energy consumption is 6. So it adds 6 to the total consumption value. It is indicated by plus equals in Python. So it deletes the 7 and writes 13 instead. And when hours passing by, it encountered, for example, 10 as the energy consumption value at that hour. So what should it write here instead of 13? Any idea?
And 3.
Yep, 23. And it calculates the total energy consumption with that approach until the simulation data finishes all the hours. And what we do is a really simple division, because we can calculate the average by dividing the total energy consumption. Let's say that it's 6,000 in total, and it is consumed in 100 hours. So the hourly average consumption value would be 6 kilowatts per hour. And there is a simple math going on after that to calculate the number of photovoltaic panels, because we know that each panel produces that amount of kilowatt in an hour. So for example, if one panel, let me write it with text, if the one panel produces 0.5 kilowatts in an hour, we know that our average hourly use is 6 kilowatt hours. We can say that we will be needing 12 panels, because each of them will produce 0.5, and it is enough to provide 6 kilowatt hour for our habitation. So it is calculated like that. Okay. Great. Basically, that's it. That's how our code works. And we will be sharing this collaboratory notebook with you. And what you need to do is really simple. You will be going to File section. And when you click, sorry, don't click to that. Refresh. No. Where was the data? Let me refresh. Yeah, here there are some sample data provided by Google, but it's not relevant for our case. What you need to do is click on upload the file option and find the data that you have downloaded. And there's a reminder, uploaded files will get deleted when this runtime is recycled, which means that in each session, you need to upload your file back again. And you can rename your file to match the file name like here, or you can do it like that. You can right click on that and select copy path option, and inside those input string you can paste your own path, so the file name will be appearing here automatically. And then what you need to do is just go to runtime section and hit run all. It will run all the cells automatically for you, or you can always go to the box that you want to run or execute and hit the play button on the left. And after calculation, if you scroll down, and this is the table that you that we are using for the conversion from kilogram to meter cube, and you will see how easy the operation multiplication operation is in Python. And these are the calculated values below each box, the maximum levels for each element in habitat in meter cubes. And if you scroll down, and there are also some description, so you can read and see how it relates with the flow chart. It's more or less sums up what I have described. And at the very below, you will see that number of photovoltaic panel needed for this layout is 27, along with the average energy consumption rate. And at the very below, you will see the total needed volume for the habitat is that much. For the greenhouse is this much, and for the storage is this much. So just try this code with your own data that you have simulated and downloaded, and try to note these values down for different layouts. Try as many layouts as you can to observe how it changes. For example, if I increase the plant that I am taking with myself to Mars, how it changes the greenhouse need in terms of meter cube, or when I increase the number of people, how my meter cube change for the habitat kind of thing. Try to run it with different scenarios and try to note these values down somewhere, copy them to another notepad or anything that you feel comfortable with, because tomorrow we will use those values to design our Martian habitats. So that's basically it. If you have any questions, anything that you want to ask.
Yes, I have a question. So these data, are they coming from the website at the beginning of our class today?
Actually, if I understand it correctly, it doesn't read the values automatically. What you need to do is go to ngs.cmoc.space, proceed, sign in. You can sign in as a guest like me, or you can create an account. Just select your preset. You can always change those values to get different results, and try to play as much as you can. And if you launch the simulation, there is an option called download simulation data. So when you download it, you can go to the Colab code, hit the file button here, upload to session page option, select your data that you have downloaded. It may take a bit time depending on your upload speed, but just wait for your data to appear here, and then right click on that copy path and just change what is inside here. Or you may change the file name, because since I'm downloading a lot of data from that, it becomes number 11. So you can also change only those values. Or you can right click on your data that you have downloaded, or and rename that file so that it reads properly, and then you are good to go. For example, let's see how it changes in action. So it was, let me write that down. The previously total needed volume for the habitat is 277. For the greenhouse, it's 503. For the storage, it's 850. And if I go to runtime and run all for the new data, you will see that it changed to 1030 meter cubes. The greenhouse is 0.39. And storage is changed to 1121. So we will be using different scenario data so that tomorrow we will generate a lot of different alternatives for different scenarios. Okay.
Also, can we have access to that mirror board? Because I wanna, see more details. Maybe.
Yeah,
I don't know.
of course.
Oh, okay.
We will be sharing the presentation with you today. So it's inside the presentation. We can also provide only the flowchart as an image itself. So you can zoom in and zoom out and see it more clearly, of course. Any other thing that you want to discuss?
I have a question.
Yep.
In the data that are in a flowchart or that we use in our code is based on the data that the information that we provide in that website. Yes, as an example, the amount of food is based on the amount of food that is produced and the amount that is consumed, and the difference between these two numbers will be the input of our data. Is it right?
Yeah, exactly. When you enter the initial conditions in the CMOC, it takes those values. Yeah, for example, let's select 4 humans in a garden layout. So, for example, if you change those values, let's make the wheat to 50, cabbage to 15, and strawberry to 5, the simulation conducts data change starting from that value, and it predicts how your wheat changes during I don't know how many days I have computed, but let's say that it's 100 days. So it starts from 50 and it predicts how this value changes over 100 days. For example, if you have a lot of people, you will see that they're eating too much. But if you produce enough plant species with you, you will be good to observe storage. Storage are enough for 4 or more people to sustain their lives during the mission.
Thank you very much.
You're welcome. And what we do in Python is this actually. Let's say that our wheat goes like that. Our strawberry goes like, I don't know, that. Onion like that. And what we calculate is we calculate the total of each day. Let's say that this is day 3. I have that amount of data, that amount of wheat, and that amount of cabbage. We sum them up and we say that, oh, we have total of 13 kilo in that day, and we do it for each day, and we say that maximum your storage will be used with 27 kilogram of total food during the whole mission. And if you build a storage that can sustain 27 kilograms for 100 days, you are good. You will be, your architecture will fit for that mission's need. Any other thing that you wonder?
I have another question. What we learned this session was about the storage spaces and how much space we need. What about something that we had in previous session and some structural or some other things that we should consider? We will have them in next session.
Yeah, the architectural part will be mostly in the next session, because till now we didn't introduce any geometry yet, but we will use some models, predefined models, to resize them, let me say, and we will try to fit our model to those volume needs. But in terms of structure and everything, we can discuss tomorrow when you see the models themselves. And it will be free to design your own models and use it, adapt it to our Grasshopper code.
Okay, thank you again.
You're welcome.
I'm a bit curious what this simulation is based on. Is it based on some data from real Mars, or yeah, I'm just a little curious about the simulation.
Yeah, very good question. I think Gizem Hocam knows more about that issue. I'm not very familiar to Martian habitation, but I assume it takes the real values from Mars in terms of extreme conditions, but it may have an assumption-based prediction algorithm, because it is not a thing that we experienced as humans. We haven't sent people to Mars yet. But.
Thanks. I also want to know more about that logic chart. About that hours part, I'm still a bit confused about the logic.
The photovoltaic thing, right?
No, the mirror bar.
This part.
Yeah.
Mm-hmm.
So this AB is totally different from the right part of the board, that AB, right?
Yeah. These are local. Actually, in this case, the A, for example, in this case, A is the fertilizer value in the storage at that day, and B is the maximum nutrient fertilizer value during the whole mission. So this A and B changes when the code passes to biomass. So A becomes the biomass in that day, and B becomes the nutrient biomass. So it's because of the level of abstraction I made. It may confuse you. Sorry for that, and I totally forgot to write A and B here. I will correct them down. And it's really a good question, because we have mentioned that Python has dynamic data types. So it's how Python handles data. A becomes fertilizer or waste as the code continues. So when the code runs, A changes according to your needs. B changes according to your needs. So it's how dynamic Python is. And for this A and B, it's totally a different story, because it's about water, and here it's about the gases inside the greenhouse. And for here, this is A. So this function does the division, like total energy consumption divided by hour count. So that's how it calculates the
yes, I understand.
Great.
Oh, and also, I remember, is this required some kind of conversion from Java to Python, or?
In terms of execution of code, or I don't know. Can you repeat your question?
So this file is in the formation of Java, or
Yeah.
I think. Oh yeah. So does it require some kind of transformation from Java to Python?
Actually, the JSON is the data type originally made for JavaScript.
Yeah.
But the file type of JSON is widely used for all the web applications. So Python handles it automatically with the import of JSON module. So it converts. Actually, it's really similar, by the way. What it does is, this is JSON format, and it converts it to a Python dictionary, and you will see how Python dictionaries are really similar to JSON format. When you see the examples, for example, yeah, this is how Python handles it, and since it's really similar, it makes the conversion automatically. And if you use JSON load method of Python, it will automatically convert it to a Python dictionary, and you're good to go.
Oh, okay, thanks.
You're welcome. By the way, that's why the Python is really popular. It handles most of the things automatically, and leave the most crucial parts to you only. So you don't focus on such unnecessary and boring details when you're coding.
Oh, so if I write some codes in Python, then I can just use it in Java as well. Just Control C and Control.
The thing is, you cannot translate your whole program to a different language.
Yeah.
But you can do this. You can take the output from Python as a JSON format. So in this case, we are taking JSON format to Python and make some calculations. But you can do vice versa. You can write your Python code to produce a JSON output, and then you can read your JSON output with another language, any other language.
Okay.
Maybe I can add. Okay, you can hear my voice. I think maybe I can add something for your first question. In this CMOC, they are using real life data for the base calculations. And as Ozan Hocam already explained it, for the other assumptions, we are just using the formulas or the organizations that explained in the CMOC with the icon. If you can explore a little bit more about this issue, for example, I will share the CMOC there. Yes. For example, in here, when you click on that icon, you can see that, for example, for photovoltaics, they explain how the photovoltaics efficiency will be. And it will help to understand how the logic is going on in the inside of the simulation.
Okay, thanks.
So is there any more questions? Maybe I can stop my sharing. Yes.
No questions from my end. I've kind of understood how it works. Excited for tomorrow.
Great. Okay, so maybe we can wrap this day. see you tomorrow to use the data that you retrieve from the Python code, and let's see how it converts to or translates into architecture tomorrow. We will be using Rhino and Grasshopper for that. Make sure you have Rhino and Grasshopper working tomorrow, and try to simulate as much scenarios as possible. And as I mentioned, try to note them down, that the meter cube values and the number of photovoltaic panels that will be needed, so that you will have a chance to observe the architectural outcomes of different scenarios in your models, because we will use the generative system. It will be really easy for you to change those values and see the outcome in real time. So it's really easy to observe different layouts generated by different inputs. Great. See you then. See you tomorrow.
Yeah.
Bye.
Bye-bye.
See you tomorrow.
See you.
Cheers.